Hello, so continuing on this contest I'm trying to solve here. So this one of the problem, so it's weekly contest 168, and one of the problem is maximum number of occurrences of a substring. So the problem says we get a string S when we return the maximum number of occurrences of any substring under the following rules. One of them is the number of unique characters in the string must be less than or equal to max letters. The number of and so the substring that we are the substrings that we will consider must follow some rules. One of them is that the number of unique characters must be less than or equal to max letters, and the substring size must be within the range min size max size. So if we take a look at this string here, and max letters is 2, and then we would have min size 3, so size is between 3 and 4. Now AAB string has 2 occurrences, this one and this one. It satisfies the condition 2, the conditions, both conditions. It has 2 unique letters A and B, and so it's less than the it's equal to max letters, so the first condition is valid, and it's in the size its size is 3, so it's in 3-4 range, right? And so okay, so let's look at this example. So this one is for A's, max letters is 1, and so there is only A, so that's valid, the first condition. Second condition, this is 4, it's not valid. Okay, so that's for AA, but if we take AA, not just one A, AA occurs 2 times, so, and unique characters is just 1A, so it's valid, but it doesn't occur 3 times. But if we look AA, so basically the substrings that we consider can overlap, so then in that case these 3 A's and these 3 A's constitute 2, and so yeah, that's what they are here. But the min size is so the size is 3, so it is within the range. Okay, so 2 conditions are valid. For this one, max letters is 2, the range is 2, 3. If we take ABC occurs here, ABC occurs here, so it occurs 2 times. Okay, now we can't take ABC because max letters is 2. Maybe we can take AAB. No, doesn't look. Maybe we can take AB. So AB occurs here, and then occurs here, so it occurs 3 times. Maximum letters, it's just 2 letters, so that's valid, the first one. The substring size is 2, and so it is within the range, and the number of its occurrences are 3, so that's why we are returning 3 here. Here the number of occurrences of it was 2, and so we are returning 2. For this here, max letters to be 2, and for the string to have 3. There is nothing that, well, we could take A, but then the size is less than 3, so it doesn't work. Okay, so now that we understand the problem, how can it be solved? Okay, so let's see how can we solve this problem. So potentially it could be either using dynamic programming because there is maximum number of some occurrences, or maybe since there are like here conditions, rules, things like that, I'm thinking maybe sliding window technique. And so we'll basically start shrinking when the condition is no longer valid, and expand when it is, right? Keep expanding as long as it is valid. And what we are looking for is the data for each window. Okay, let's try with this. So data for window is actually number of unique characters and plus substring, right? So so the windows would be, we would have a start for the window and an ending, right? So we need two things, I and j, that represent the window. And while charts starts out as 1. And then I have the window itself, right? So we know that if Okay, so I solved it using this method here, but I solved it using this method. So let's take a look at other people's solution for a second here. Let's take a look at these two and see what people are doing for it. This one is similar to my solution, right? Yeah, so he used the same idea that I used, which is that min size will always get you the largest frequency, right? So we can just check it. And same thing, word in a dictionary to count its occurrences so that we can use it as we encounter it. And then here, yeah, this is just check the max letters. Then he adds, okay, otherwise he doesn't count it. Okay, what is that? So that's similar to this. Yeah, I just checked this, but this I do it every time because, yeah, why not? Yeah, he's doing this. What I'm doing is just taking the best every time, right? Which makes sense. This idea so for a second count. So max size less than or equal to 26, it would still be constant. Is that what they said? So conditions say max min size, they are between 26 and the length. We have only lowercase English letters. Yeah, so this is similar to what I tried here, where basically he's doing the range from min size to max size, right? And then trying those sizes, right? Which got him a TLE, right? But checking if the result, like, we obtained something, right? So if we obtained something, there is no reason to keep going. We can just break out of this for loop, right? Because we found something with a smaller size, right? So it doesn't matter anymore, right? So I think this one is pretty clear, because once we find something with a smaller size, right, then I think this is more convincing than supposing min size, right? Because once we find the result for a smaller size, there is no reason to keep going, right? Yeah. Because maybe it's just that the constraints aren't good enough. Yeah, this is a good justification for it, right? Oh wow, he's back. So basically what he's doing is taking every character and taking each portion and selecting and then grouping, right? Mm-hmm. Yeah, I think no need to overcomplicate things. We could just start out with this, and yeah, we will be doing all the necessary verifying all the necessary conditions, and that would pretty much be it. I think. Yeah. Okay. This one was interesting. So we have the counts, and we go through the I, and then unique characters each time. It's a set, and we have a set of characters, right, that we are exploring, right? And then we start from I, and the minimum of adding max size. So these are potential endings, right? So we add the character, so this is the one we are exploring now, and so we add it to both, right? So we check if unique characters, so we add it to the unique characters, right? And we check if the length is bigger than max letter, then the condition is violated. We add it to the list of characters, so that we could check that it's in the min size. If it is, then we add that string, and chars here basically is just si to j, right? Yeah, so I think we could just here, instead of doing this, we could just say sij. Sij plus 1, right? And no need to do this. No need to have this. Just use that. Yeah, this one should work, I think, and it looks good. Yeah, and you could argue that you don't need to do this, right? You don't need this set. You can just do set here, right? And that would be pretty good too. So that would be something like this. So this is similar to this, except here we could, instead of doing this, we could do it a slightly different way, which is, well, let's just take this, and instead of checking the length, well, let's just do I plus min size, right? That will guarantee that the length here is good. And we could just do that. Okay, didn't work for that one. I think it's -1 maybe. Yep. So only valid words would be, so try all the starts, try all the endings, and check that it's valid, and increase the count of only those that are valid and take the maximum one, right? Pretty straightforward, yep. Okay. Okay, let's solve it this way then. Yeah, I think that's it for this problem. This should be good enough. Yeah, cool. Yeah, so thanks for watching and see you next time. Bye.